Hello everyone. In this code we are going to demonstrate about the time series decomposition. It takes time-based data collected over the months or years, and separate it into three main components. First one is a trend, which is long-term increase or decrease pattern. Second is the seasonality, which is a repeating pattern at a fixed intervals. For example, yearly, monthly pattern. Then third one is a residual or the noise, which means the random changes that cannot be explained by trend or the seasonality. So this techniques is commonly used in time series analysis, forecasting, sales, prediction, weather analysis and stock analysis, etc. So in this code we firstly import the required libraries. So first one is a pandas. Here is a pandas, which is used for handling time-based data and creating the series. Second one is a numpy, which is used for mathematical operations and the generating the data. And the third one is matplot library.pyplot, which is used for the plotting the graph. Then we are creating a simulated time series data. For this, we use np.random series 42, which sets a fixed random value. It ensures that every time the program runs, the same random noise values are generated. And then the time PD date range starts from 2021 1st of January, which has periods of 48 and frequencies me, which creates a date range where starting date is 20 January 2020, which has periods 48, that means create a 48 times points, and frequency me, that means monthly frequency. ME is that month end. So the data represents 48 months of the data from 2020 to 2023. Then we creating a trend. Here we creating a trend component which creates an increasing trend for the upward trend, which is a line space, which generates eventually spaced values. And that means the data slowly increasing over the time. Then we're creating a seasonal. Here we're creating a seasonal pattern. In this creates a repeating yearly pattern. SIN, which is creates a wave-like pattern. 12 represents 12 months in the year, and the pattern repeats every 12 months, which represent the seasonal behavior. And then here we are adding the random noise, which creates a random variations, which where noise represents unexpected events, random fluctuations, measurements, errors. Then we creating a final time series data. Here we creating final time series data, which is by combining the trend, seasonality and the noise. Then we create a pandas time series by using ts is equal to pd dot series. Uh, then trend extraction using a moving average. Window is equal to 12, that means 12-month window is get selected because the data has yearly seasonality. Then trend component here, which moving average method. So moving average moves the data by calculating the average of the nearby values. Then for the 12 months average of January to December values, that means. Then extracting the seasonality. So seasonal dot component, which is used to remove the trend from the original data. Then seasonal means this use for the groups data by the month. Then season component, which is assigned the calculated seasonal values to the every month. Then residual or the noise, which removes both trend and seasonality. Here, which removes both trend and the seasonality, and seasonality. Okay. Then for the visualization, we use plt.figure. So the plt.figure size, which create figure size of the 10 into 8 inches. So the first graph is the original time series. here, which shows the complete data which contains trend, seasonality and the noise. And then the second graph is for the trend, which shows the only long-term movement, expected output as an upward smooth line. That means data is increasing over the time. The third graph is the seasonability, which shows repeating yearly pattern, which like a wave-like pattern. That means the same pattern repeats every 12 month. And the fourth graph here is the residual or the noise, which shows the random errors. That means a line fluctuating around a zero here. And we show the graph by using plt.show function. So here is the output of the code. So first graph is the original graph, which is the combination of the all component, which shows the actual time series behavior. Here is the actual time series behavior. The second one is the trend graph, which is smooth increasing line, which shows the long-term growth. Then the third graph is a seasonability graph, which is a repeating wave pattern. That means shows the yearly cycles. And fourth one is a residual or the noise graph, which is random ups and downs, which shows the noise error. Overall, this code demonstrates how the time series dataset can be separated into meaningful parts before applying forecasting techniques.